exam, which is a triangle inscribed inside a circle. And again, there's more to this than we'll necessarily cover in this one class. So there's more that I'd like you to cover, especially volumes and multi-sided figures that we haven't discussed today. But we're really covering the basics, reintroducing everybody to something that some of us haven't seen for over 25 years. Oh my goodness. And this is it, finally. This is the day that they told us about when geometry would save our lives. In as much as it will help get you into graduate school, and in as much as it helps me earn a paycheck, then geometry is saving our life right now. So they really meant it when they said that. So if you could scroll down a couple inches on this page, and you'll see here is a triangle inscribed inside a circle. Now, again, don't believe them for a second when they give you a sketch. Draw your own sketch. You always want to be suspicious of this test, because the second you assume anything or give it the benefit of the doubt, it will punish you for that. So we can only go based on what we know from solid information. Now, one thing is that I've never ever seen the GMAT try to be so tricky as to give you, this center point, or this, point on the triangle, and not be dead center on the circle. So you don't have to worry about that. It's not that clever. If they show you a triangle that's going to what appears to be the center of the circle, it is the center. It's just not that smart. So based on that, there are a few things we can deduce so far, but only so much. So what do we know? Well, the distance from the center to just touching the outside, we know that's the radius. And I don't know if it's just me, or maybe this is the same for you. It took me a second to visualize this connection, but and maybe it's an optical illusion in this one, but logically, since this side that we're looking at here also goes from the center to exactly touching the edge of the circle, then it's also the radius, and it's also, exactly equal to this side. These two sides are each equal to r. We don't have a number yet. What we do know as far as numbers is that the whole circle has 360 degrees. We know the triangle has 180 degrees. And we could tell you that, okay, so, well, we can take it a step further, but without any values, we're only going to be able to take this so far. We know that these two angles are equal. So you could call that, I don't know, angle R. We would know that this angle is 180 degrees minus 2 times angle R. Now, can we conclude then, since this is 1 to 1, these two sides are equal, these two angles are equal, can we conclude that this side here is going to be R times square root of 2? Right. So you voted for it before you voted against it, Sarah. Is that right?
Yeah. Yeah.
Right. I
We
mean,
don't know it's a right triangle yet.
perfectly designed to. They set it up. It is drawn as a right triangle, but we can't assume that unless they tell us. So since they haven't told us this is a right triangle, it may be a right triangle, in which case it would be r to r times square root of 2. And then it would be 45, 45, 90, and then everything else that comes with that. But until they tell us that 90 degrees, we don't have any numbers that we can plug into this, anything further than what I've exhausted here, right? The 180 and the 360.
Mm-hmm.
Now, if they give us that one additional piece of information, now knowing it's a right angle, then we can conclude that these two angles must be equal to, yes, you,
Oh, that they're each 45 degrees.
right? And what's the name of this kind of triangle?
A right isosceles triangle, or isosceles right triangle.
Good. And that's the only one that they will give you, like in isolation, to say, if you have an isosceles triangle, you know, what's the ratio? And it's something that if you don't know the name, there won't be anywhere for you to solve it. So that's why I keep harping on that one. If they give us that one piece of information, you know, we can only go on solid ground. Okay, once we know that, then we can say, okay, well, this is a 45, 45, 90 triangle. We know these two sides are equal. We know this side exists in a ratio of r times square root of 2. Let's see, can't take it too much further than that. We know the diameter is equal to 2 times the radius. Can you tell me, let's see.
You know that the arc is a quarter of the circumference.
Right, and so take that one step further. How many degrees is that?
What do you mean, how many degrees?
How many degrees angle would it be from this point to this point for this arc?
90 degrees.
Yeah. Now that is a direct one-to-one correlation. If this is a 90-degree angle, this is exactly 1/4 of a 360-degree circle. So 90 degrees equivalent to 1/4 of the entire 360. So if I gave you a value that r equals, I don't know, r equals 2, we don't necessarily have to calculate it out, but then we can calculate the area, because that's pi r squared. We can calculate the circumference, which is just the distance around the circle. That's 2 pi r. And then you could calculate the length of any of these arcs, because those are a one-to-one relationship. That's 1/4 of the total circumference, because it's 90 degrees. If it were 45 degrees, what fraction would it be?
1/8.
And just quick gut check, what's the decimal conversion for 1/8?
0.125.
0.125. Knowing how to just really quickly go back and forth between fractions and decimals up to 1/12 will serve you very, very well. And I learned that as a bachelor in college, Sarah, doing my shopping at the like generic stores or whatever, being able to quickly make those conversions in my head made shopping cheaper, faster. I don't know. Okay, thank you. So that's about all you need to know about